This is Greg Marshall. I'm the disembodied voice introducing Jim. Jim Vomero is going to be covering practical CS. I assume that stands for computer science, memory allocation, and garbage collection in PHP. And he's promised to tell me how to get a better rate from waste management.
You got
Right?
it. You nailed it. Well, thank you for the
Well,
introduction.
Jim, and get off this.
Excellent. Thank you for that. Yes, this is practical computer science.
One last thing before you.
Oh, yes.
If you have questions, please put them in the session chat, and we'll cover them at the end or during or whatever.
Perfect. I'll do my best to keep a pulse on there because I'll gladly entertain questions as they come, but I just don't promise to keep looking off to my side screen. And yes, I have a lot to talk about. So if anyone else wants to drop in the chat, the session chat, what their level of PHP experience is, I will gladly customize the language of this to meet your skills. But otherwise, I'm going to assume that we're all comfortable, but not pros. I'm not a PHP contributor, but I do like to peek at the internals and figure out how my code is being executed. So today, I want to realize and think that our programs are running on metal. We're so far removed from these physical components. And the fact that these interpreted languages are so flexible, we don't think about the ones and zeros being stored in circuit boards, but memory does matter. And understanding some of the fundamentals will help us get a better sense of how our programs are working and maybe make you feel more empowered to make technical architecture decisions, even in small functions, to minimize your memory footprint in PHP. My name is Jim Vomero, and I'm an engineer at 4 Kitchens. I have over 10 years experience in Drupal, and I use it for all my nerdy hobbies, from planning my homebrew beer days to planning out retro arcade cabinets, to even running summer camps to teach local kids in the Philadelphia area how to survive the zombie apocalypse. Yes, that's a thing. I hope you leave this presentation with lots of questions because I've introduced you to something new. Feel free to follow up with me on any of these social channels. I'm njim, and I would love to talk shop after this and keep the conversation going. I work at 4 Kitchens, and we work with associations, publishers, enterprise organizations, media, and higher education, and we make big websites. So we're specifically talking about RAM, or random access memory. Random meaning that we don't always know where things are going to be stored, although there are some general rules. So memory, and I have it kind of illustrated here as a grid, has places where you can store things. I'm going to try to keep it generic, the language, because it is flexible. But the way this storage is allocated can change. So there might be one section that is very static information for your code. Your program is loaded from your hard drive into memory as plain text or some sort of compiled or machine language. There's another section called stack memory, and we're going to look at that a little bit. It has certain rules it obeys. And there's another section called heap memory. And there's more beyond these 3 I have illustrated. There's also spaces left in between so that maybe the heap can grow if it needs a little more room without another process on your computer interrupting this space that's been allocated. I'm going to look at these different types of memory and talk about some of the pros and cons and then how PHP leverages them. But at the core, they are all the same thing. We're storing things, we're using and retrieving information from there, and then we release that memory when we're done with it. I'm also going to tell you the truth, nothing but the truth, but certainly not the whole truth in this presentation. I will point out a few of the spots where, if you're interested, you can dive more into PHP internals and get the complete story. Let's start with stack memory. This is a computer science session, so we are going to dive into some of the basics, and we're going to use C++ and maybe C notation to talk about some of these things. So stack memory is a continuous block of memory. And when we have a short program, let's say just initializing 3 variables here. Integer called level, that's 1. This is like for a video game. The player's name, JIM, with some sort of termination code. And we have an inventory, and right now it just has the word sword in it. All this memory is in a continuous block, not just in this diagram, but physically on the chip. And that matters because things like changing the type become difficult. If I wanted to change level from an int to a string, the compiler is going to say this is not possible. Invalid type conversion between the two. It has to be an int. I can't grow beyond the original allocation when something's in a stack memory. So I wanted to change my name because this is a quest game from Jim to Sir Jim. And SIR fits, and that's out of space because all these things, and of course our program might have hundreds or thousands of things stored in the stack memory at some point. They're all next to each other in these continuous blocks, and I can't just shift things down. So we've made a conscious decision. Anything in the stack gets a fixed amount of space, and you can change the things in there, but you can't grow beyond it. And really just small variables belong in the stack. When we were looking at that diagram, which was not to scale, the stack memory is one of the thinner strips. And the size of a stack for a process is going to depend on your hardware, the architecture, along with some other software rules. But it's small. It's not where you put big variables. And if you try to, let's say inventory for this video game was an object that had thousands of items in it, each with its own properties, that's too big for the stack. It's so many kilobytes beyond what it can take, or if you're on Windows, so many megabytes beyond what Windows will allow. And you get a Stack Overflow error. And finally, memory on the stack is freed once the stack frame is popped off. And this is one I'm going to kind of glaze over, but if you're interested in stack frames, you can actually see a lot of interesting examples online. So main, this program where we started, allocated some memory to 3 variables. And then at some point in the program, we get to this if can access k. We're going to see if the user has the key or has enough power. And there's a variable in this function called min power equals 100. A new stack frame starts right on top. They all go on top of the stack, and it has a variable of 100. And new variables keep getting added to the top. And once we leave the function, all of that memory is wiped out on its own. We don't have to worry about it. It's automatically freed, leaving just the variables below. This is nice, but this is limiting. In C++, we're going to need a place for long-term storage. We're going to need to be able to change what's in these, add an item to the inventory. And we need flexibility. And of course, in PHP, we're used to changing types. So we need another way to store things. And that's going to be heap memory. And I do a whole talk on heap versus stack memory. It's an hour long. You're just getting the highlights today. Hopefully the hits. Heap memory. My analogy would be at a restaurant. My partner and I go up to the host and say, I'd like a table for 2. And we might be, as a party of 2, put it at a table of 2, or it might be at a table of 4, whatever's available, maybe a table of 6, or all the tables are busy, but there's seats at the bar and we can find 2 seats together at the bar. That's fine. We're placed wherever it makes sense. It can be fairly random. In fact, it's super unlikely that the people behind me in line are going to be at the table next to me, and the people behind them are at the table next to them. They're allocated wherever it makes sense. So that's memory allocation. Then there's the access of the memory, works just like it did on the stack. People can read these variables. Reallocation is resizing of these things. I'm at a table of 2 with my partner, and our neighbors across the street wave, and we do the plate. Hey, do you want to have dinner with us? And so they ask, oh, maybe we can pull 2 tables there next to each other together. Or maybe I'm at a table of 4 and there's empty chairs, and I say, well, have a seat and join us. So that's reallocation. We can move where the memory is freely with just some commands in C++. And then freeing. On the stack, when we've reached the end of a block of code, the end of a function, the memory was automatically popped off. This doesn't happen in the heap. We need to be very aware of where our memory is situated in RAM. And at the end, when we're done with it, we have to tell the program that we're done with it and free that memory. So I guess in the restaurant analogy, it's we want to bus all our tables so someone else can sit there in the future. And if you don't, you have a memory leak. And that's not a term we talk about a lot in PHP, and I'll talk about a little bit why in a few slides. This actually sounds like a dream. We have a lot more flexibility, but it comes at a cost. And the biggest one is performance. In the stack, everything was stored right next to each other. And so the CPU didn't have to spend time chasing down data because every variable was literally next to the last one in the order that it was required. So if you were 3 functions deep and then you were slowly moving back out, you're just moving down the stack. In the heap, these things can be anywhere. It's seated outside. Maybe there's a special table in the corner that someone popped up because the restaurant was full. So the CPU has to chase down where everything is and keep track of that continuously. How does this work? Well, they work together, and we're still in C++ land here. I have a small program with just a couple of highlights. We're going to create an elevation variable. And what this does is we don't have a value yet. It's going to be, it looks like an integer. So we've saved some space for this integer, but we've hopped into a function, get elevation. And one of the first things we encounter is a variable for longitude. And because of the notation, we're saying, let's store this on the heap. So longitude is stored on the heap as 42. And to keep track of it, a pointer is stored on the stack. And so this is a pointer. You're going to see the same type of drawing in PHP examples in a bit. And there I'm going to call it a reference. But here, this is a pointer. So it's a very small variable on the stack, which is efficient and fast, pointing to a very malleable and flexible variable on the heap. In this case, 42. We create another one for 75. And then, I don't know, we call some APIs or we do something to get the geographic information. It comes out as this big honking data element. And so now we have one more variable, data, and it's this big object here. We return data and our program keeps continuing. Now, because get elevation, this function is complete, these values are going to pop off. The stack frame is going to be removed. However, we never told the program to get rid of what was in the heap. And so we've now created a memory leak where the memory is still allocated. Those tables are still messy. They haven't been bussed, but we can no longer access it. We don't have our pointers to that information anymore. And so this is something we have to be very careful of in these lower level languages. And you might say, why do I care? I'm in PHP land. And looking at the chat, we have various degrees of comfort in PHP. But you might all be thinking, if this is a new topic to you, why does this matter? And it's because the PHP interpreter is written in C. And all of the aforementioned rules that I mentioned apply, even if they don't feel like it. So we have an array of ducks, Huey, Dewey, and Louie. I can add another one, Daffy. I can add another one, Rubber Ducky. And you say, well, that's resizing. And the answer is because PHP generally leverages the heap whenever it makes sense. And so when you have immutable or when you have mutable arrays, those values are probably stored on the heap. So I'm going to boil it down and say a lot is stored on the heap in PHP, if not everything that we care about, with the big asterisk that PHP 7 has a lot of efficiencies that we don't need to worry about. It might actually correct what I just said. The bigger one here is both the heap and the stack in C++. You cannot change your variable type. I had that on both the previous slides, although I didn't fixate on it too much. We do this all the time in PHP. You know, count equals false, count equals the int 3, count equals null, count equals an array. That's valid PHP code. And this is where I have to get pedantic. The variable is not changing its type. This is the same variable type. The value is changing its type. And that's what we're used to working with in PHP. The type of the value can be bool or int or null or array. But the variable is one single type. In fact, all of our variables in PHP are going to be something called a ZVAL. Whoa, what is that? The ZendVal. So the Zend engine has this concept of a ZVAL. And it's a union of all the different types that we may care about, and from null to object to string. The ZVAL, when it's created for a variable, is going to allocate two 64-bit words. And in C or C++, if you wanted just a character, the letter D, you might have 4 bits associated with that. But it doesn't matter what you're storing in PHP, you're automatically going to get 128 bits allocated for it, even if you're just storing null. 128 guaranteed. So maybe that's something to keep in mind, just how you use your variables. They are taking up memory. And if you have some long or intense processes, feel free to unset some of those just to free up memory where it makes sense. How this works, the value can be stored in the value here or as a reference to somewhere else, like on the heap. And there's also this thing called a ref type count flag. So there's several flags, and the one we're curious about today is about reference types. This is as far as I'm going to go into the ZVals, other than just acknowledging that they exist. And it's the sort of monolithic way we store all of our types of values into a single variable type in PHP. Whew, the wording of that was important. And what does this look like? Okay, we are allocating space for 4 variables. Ada is the name. And so we have a ZVal, and it's going to point to a value here called Ada. Clan is null, so it doesn't point to anything. And hit points is an int 157. You can change that to a string later. That's fine. The metadata is updated for hit points, and it points to the new space. And inventory, in this case, is an array, so it points to a set of ZVals, each one at their own spot. And while I have them kind of in order here, they really can be all over the place, fairly far from each other in the physical space in the computer. I'll also say this is the slide that lies the most. PHP does a lot of things to make our code efficient, especially PHP 7. It will do things like assume strings are immutable or arrays are immutable and store them in ways that make them easy to cache. So this is a good introduction if we're talking about references and ZVals, But as far as actual application goes, PHP is going to take over and do some fancy things, so it wouldn't actually look like this. So take it at face value, you're getting the truth, and hopefully nothing but the truth, but not the whole truth. This brings in this idea of references that I mentioned before. We have a simple assignment. Variable A is hammer. B equals A, C equals B. And it's a string. And if we were to var dump these, we'll see hammer, hammer, hammer. As far as PHP is concerned, we have three separate ZVals, A, B, and C. Yeah, they are in order. And they're all pointing to the same value. There's a function if you have xdebug enabled called xdebug debug zval, where you can get a little bit of a look into what is happening in this allocation. You see a ref count of 3. I do have this available in some code samples. We may check it out later. There's some questions on it. So the ref count is 3, meaning this value has 3 variables pointing to it, and isRef is 0. Keep that in mind for right now, but we'll dive into that later. Let's say we want to change B, we're going to change to chisel, and we're going to do it down here. So B was hammer, and then it got changed to chisel. If you were to var dump this, what we're going to see is only B changed to chisel. The other two are still pointing to hammer. And it wouldn't necessarily work in this in all languages, but this is fairly true. What PHP is doing, and this is going to come up again, is copy on write. It's storing, it recognizes that all 3 of these have the same value of hammer. So there was no reason to have 3 times the string hammer in this heap memory when it could just point all of them. But as soon as one of the values was changed, it was time to reallocate a block of memory to have this different value. And so now we have the reference count as well changed. A and B have a reference count of 2, and B has a reference count of 1 pointing to chisel. I'm saying reference, but that also means something in PHP. And if you've done assignment by reference, and certainly I think we've all done this in Drupal world because we use hooks and things are passed by reference. You have that nice ampersand. In this case, A, B, and C are all references. They all have this reference value, and I guess you could call them aliases as they do in the documentation of the same value. So it doesn't matter which variable you access. If you access B and change it to chisel, all 3 of them will continue to point to the same value. Now all 3 of them are chisel, var dump, chisel, chisel, chisel. In this case, reference count is still 3, but isRef, this flag, this metadata in the ZVal, is a 1, meaning that these pieces relate to one another, and there's going to be some implications. It's not going to have that copy on write effect. This is references. It's similar to pointers, and it certainly is going to affect memory management. I would say the 2 biggest takeaways I have from this, and I'm already seeing it in the chat a little, when it comes to this copy on write, be cautious of what you're passing into functions. Not everything needs to be an array for starters. But I'm sorry, let me go a little slower. All right, first takeaway, not everything needs to be an array. Arrays get expensive. And if I were to go back to this one, an array inside array inside array inside array, each one of these has its own Z value. So I guess my first takeaway is don't use arrays if you don't need to, because each one of these has that metadata established with it. If you can use a smaller or more appropriate data structure, please do, because then you're not penalized for what might be an array of a ton of zeros, including all this metadata at 128 bits per allocation. The second one is leverage write on copy, or copy on write when you can. So if I pass a function, a giant node object, it won't automatically allocate more memory until it needs to. I actually have an example of that. I think it's my last example. So leverage copy on write when it makes sense, and we'll do an example of that. And use this version of assigning by reference when it makes sense. So the node hooks is a great example of that, something we probably use regularly in Drupal space. We don't need to create a separate instance of something when we actually want to modify a single place for it. Garbage collection, I'm going to talk a little bit about that last one. So this is an oversimplified example. We have an entity, it's a large object in Drupal, node 123, and I pass it to a function update owner. Now, originally a ZVal is created for this entity, and it's going to point to a big blob of data, which of course has its own ZVals for everything as you traverse the structure of the entity. So big old blob of data, ref count is 1. Entity gets passed to update owner, which has a parameter called node. And so node is here as its own ZVal, but because there's been no writes to node, it's going to point to the same place, and ref count is 2. We saw this in the last example. On the next line of this code, though, we're going to change the node variable. And I am oversimplifying what's happening, but I kind of want to just illustrate the copy on write. So now we need a new instance of this variable. Each one has its own ref count, and it means that we've doubled the memory being used just in this little piece of code. And then we end this function. We get to the end, the stack variable pops off, and this might seem like, oh crap, there's going to be a memory leak, right? We didn't unset it, but we never remove variables like that in PHP. Garbage collection has our back. So when you hit the end of a function, the ref count for that object and anything associated with it is going to decrease by 1. And if the ref count ever gets to 0, then the garbage collector function removes it from memory for us. So it's something we generally don't have to worry about. Garbage collection got our back. There are some cases where we can screw it up and create some memory leaks, and I have an example in GitHub that I'll share with you at the end. There's another way we can free up memory. And so let's say we update the owner, but this program continues, and we don't actually need this entity anymore. A bunch of things are happening. Well, this is still sitting in memory because it has a ref count of 1. Garbage collection is not going to get rid of it. Unset. We can unset variables at any time. That will remove one count of references. So that went from 1 to 0. Garbage collection cleans it up for us. So feel free to judiciously unset variables. That's one way to minimize your memory footprint. And the other is to use small methods that are focused just on the data that you need. So in this case, I did want to pass the entire node, but there's sometimes I might just pass a node ID because I don't want to risk creating a second instance of that node. All right, that was a lot of talk. Let's look at some code. Everything I have is on GitHub, and I have the link on the last slide. So very first, let's just talk about how we measure memory. There are 2 functions in PHP that are very useful right off the bat: memory get usage and memory get peak usage. So in my example, I am echoing the usage in megabytes, doing some rounding, some math to make it pretty on our eyes. Because even before this file runs, some amount of memory is allocated for this process. So we get the initial usage, and then I create a big variable. It's an array with, what is this, 100,000 items in it. All of them are 0. So it's just 0, 0, 0 over again. And so after creating that array, let's get the usage again. Then let's unset it, get the usage a third time. And finally, let's check out this peak usage, which is going to look over the lifetime of this process. What was the peak usage for this script? I am using Lando as my Docker container here. And let's see, 01. And this is on an old machine, so I have a release. So forgive my embarrassment. I need to update my Lando. Initial usage, 236K. We created that array, and it jumped up to 1,400 or 14,000K. We unsetted, and it jumped back down to about where the initial memory usage was, and we could see the peak was when that array existed. So feel free to use these to get an idea of what's going on in your programs. They're no substitute for a memory profile because, in fact, just by me measuring the thing, I've changed the thing, and it's something you'll get annoyed with pretty quickly. But this is accessible. This is included in PHP. I can run this whenever I want just to see how things are going. It's a good way to get a health check on your scripts. If you want to get more involved, there's some wonderful profiling tools and testing environments, but they're going to take some work to set up. I'm going to skip the next few files, but I'll include the link in case you're curious. This is the example I did on slide. I think I had hammer and chisel, but here it's time and space. And then likewise with references, you change one and the others change with it, because I want to show some garbage collection. So here is a function, and I'm going to check the initial usage just like before. I want to see how much is going on just so we don't lose sight of that. And then I have a function I'm calling data party. And in data party, I'm creating an array. It's that big array I had before. And we can see how much memory is being used while I'm inside the data party function. This variable was created. And then it goes out of scope. The reference counter should be decreased by 1. And when we're back into the main program, we should see the memory went back down. Let's take a look. Make sure the garbage collector did its job. It did. So we are at 237K. We jumped up while we were in the function. We got to the end. That reference count was decreased, and we went back to 237K. So garbage collection feels like a set it and forget it. Feels like a win. It's something to be aware of because it's a tool and it's something we hear in computer science, but it's something we rarely talk about in PHP land. And where do we maybe want to be cautious and measure more? Circular references is a great example. And it's one that I've certainly seen in my own work. If you have a menu structure and a page has a child page, and that child has a child that's actually another parent, you can get into a point where you have references that are circularly dependent on each other. And so when you're building this menu, you have a parent with a child who's a reference to the child, et cetera, et cetera. And it screws up the garbage collecting. So in my example, I have a child and a parent on a person object. And just so that there's a memory footprint, I just have it creating that array inside. So each one is, a beefy size in memory. My main function here is family tree. And so there's me, I'm a person, hooray. And my daughter, Gwen, she's a person too. Gwen is set as my child. I am set as Gwen parent. And while we're in this family tree function, we're going to get the memory usage. I have a utility function in here just because I was sick of writing out all that stuff. So it is still just using the PHP get memory usage. I just wanted a cleaner way of showing it off. All right, back to the garbage collection file. So that is, circular reference file. Come on. So that is my family tree function. It creates a gem object, a Gwen object. It sets relationships to each other, and we're going to check the memory usage while we're inside. The main program, we're going to check the initial memory usage. We'll get a report of the memory usage once we're inside. When this family tree ends, the gem and the Gwen object will each get their ref count dropped by 1, and we'll check the final memory usage even though we're outside of this. It's probably not surprising that something ugly is going to happen because why else would I be setting it up this way? Circular reference. There's initially 245K before my script really gets started in earnest. I jump into the function and we have 3 megs, creating those 2 big old objects with references to each other. I leave that function, the memory's still allocated. And so what's happening here is Jim has a ref count of 2 itself and its reference inside as a parent of Gwen. And Gwen likewise has a ref count of 2. When it gets to the end of this parenthesis, this is going to remove or decrement the ref count for each of these variables by 1. So they never actually get to 0. They stay at 1. PHP's garbage collector will not clean it up. At least this garbage collector won't clean it up if the reference count is 1. And now we have a memory leak. There's 2 ways to solve this. The first would be to create some sort of function to clean up your mess. We can manually remove these references. There is a destruct in PHP, but this isn't going to be as immediate as we need. We need something to happen earlier in the function. And there are things called dereferencing methods. There are some projects that try to bring this into PHP. It's in other languages. So you could take a peek, like PHP weakref, but it's not something I've ever implemented. So another reason to measure is just to see if you run into issues like this. Luckily, PHP does have our back. They have a second garbage collector just to deal with this issue. And I would like to show that off. It's the PHP function gc collect cycles. So I have the same thing happening here. Person has a parent, child, and it has a bunch of data just so we can see some megabytes. I'm going to hide my answer there so we can go through it together. The only thing I'm doing, same thing as last time, is I'm calling that family tree. And if you remember, every time this runs, there's a memory leak because it creates 2 objects and then can't delete them. I'm going to check the memory usage after every 100, and I'm going to run this 10,000 times. So 10,000 times, I'm going to create my 2 persons and let the memory leak. And pay attention to the speed that this runs at. Did you see that pause? The kind of like stutter it does? That's important. That's not a glitch in Hop-In or anything of that nature. We're checking the memory usage every 100 items. And so it's increasing. The memory is continuing to leak as this goes. And I should mention, folks might feel compelled to say, well, PHP is kind of a short life. We Someone requests a web page and we return a web page. It's done within fractions of a second. And that is true a lot. So we're not as worried about memory in that sense. But if you've worked on a migration or you've worked on some more like messaging active processes, PHP is going in a direction where this kind of stuff is going to be important more and more. So we see the memories increasing, and we get up to 300, 400 meg. And then finally, when we get to, let me just double check, going too fast for myself. When we get to iteration 2500, the usage drops back down to a more sensible number. And this repeats. There's at 2500. And then at 5000, we're going too fast. At 5000, it drops back down, 7500, and then at the end of this program too. So what is happening? There is a function in PHP, and it's a buffer that's going to store all the objects that are currently in use. And it's going to keep track of them. When that object buffer gets full at 5,000 items, so you saw it at 2,500 because there's 2 people every time it runs. So when that object buffer gets full at 25 items, it pauses the execution of your PHP script, and it checks every one of those objects to see if it is still in use in the code. Not caring about that reference counter because it might be wrong. There might be a memory leak. It will check every item, remove the ones that are no longer in use for this script, and then unpause your program. And so it's nice to know that PHP has your back if things go awry, but this is not the mechanism you want to rely on, because I'm going to run it again just because it was fun to watch, because it is literally halting execution to run this this process to check all these leaked objects. It's a GC garbage collect. The last problem I have, and I realize I'm hitting time, but this is my last thing, so I at least want to introduce it, is showing off different ways to handle a simple problem. And so my problem is I have a large array, and it's a color array. It has 1 million items, and the items are all red, yellow, or green in random order. Just 1 million items, red, yellow, green. And I want a count of how many of these things are not green. There's a lot of ways that we can tackle this problem, and it's good to get a baseline. And no PHP. What is this one? This is number 7. Even before doing the filter, we are creating a big array here in color. So it's currently using 92 meg. My first solution is let's unset all the ones that aren't green. So we take this list of all the colors, we've passed it in, it was called colors, now it's data. And we're going to just do a for loop. And if it's green, we unset it, and then we count how many are left. That's one super simple example. I'm sure I've done something like that before. Let's save. What we've seen is the peak memory usage has doubled, 184 megs. What's happening is our colors array, which was in the 90s, was passed to data. And that creates that sort of soft copy again. But as soon as we alter it, we have a copy on write. So now we've doubled our memory usage within this function because we've altered this original piece of data. A different way to tackle it, the loop and count method, does not alter this data. So it creates that soft reference, but it never changes it. PHP doesn't need to allocate more memory, because in this case, we're going to do the same loop through, and we're just going to count everyone that's not green. And we're still now at 92 megs. So the same amount of memory peak for this method. And so this is where I had said before, you want to be careful, but use that copy on write feature to your advantage. So if you're passing a large data object and you're changing it, recognize that you've now created a bigger memory footprint for your project. I do have some other examples. I'm only going to look at 2 of them though. For each. So this is the exact same as my original one. This one doubled the memory usage. We used a for loop and we unset it. Except this time I'm going to use a for each. And in this case, we've tripled our memory usage. For each is yet again creating a copy of this. So now we have 3 instances of the same data being altered. And I guess this is where you start to have to be cautious of what you're using in your language. Understand what's going on. A for loop versus a for each loop is going to have a different memory footprint. And the best advice I've been given over the years is use native functions wherever you can. So in this case, array count values is a native PHP function. Array filter is also a native PHP function, and array diff is a native PHP function. Array diff actually still uses twice the footprint. It is looping through, it is altering, so it is not a great use case. 191 peak memory. Array, oops. Sorry if I'm getting anyone seasick. Array filter is using more than 1 times memory, so it's an okay solution, but a for loop would have been better. And then our absolute best one as far as native functions go, array count values. And this is using the same as that for loop. It's using the minimum memory footprint. In this case, actually for all 3 of these, because these are native functions, they are written in something C or something like C, so they are going to run much faster than any of the code that we have that's interpreted. Happy to answer some questions at the end of this if you're interested, but I have to tidy up this presentation. So takeaways: don't abuse arrays. Be cautious with copy on write. Recognize it exists and can minimize your memory footprint. Unset variables that aren't needed. Use small functions, and that garbage collection will take care of things right away rather than large, procedural code. And start using these functions to monitor your memory usage, even just to get baselines. They're for you. They're not as good as a profiling tool, but they are very useful. With that, thank you so much. There's a link to my GitHub that has all those code examples, so feel free to run them yourself. And feel free to reach out to me. I'd love to keep this conversation going. Are there any questions?
If you put the questions in the session chat, so on the right, there's event and session, click on session, and use the chat there.
Well, thank you all. What is a common mistake in Drupal? I'm not going to give you the most programmer desired answer, but it's really just not knowing what your current memory footprint is. Most places that I've gone in to help with a project, if someone hires me, they will say they want their site to be fast, but they don't have a way to quantify what that means. And so certainly at different points in your development lifecycle, you should get a read of what performant is, put it in writing, and realize that every time you make a change to your code, you're probably, in adding features, you're probably making it less performant, and that there is a threshold that you're not willing to pass. So it might be having a budget for memory. I would say in Drupal, this becomes even more of an issue because we're so quick to add a new module just because it exists and it gets the job done without recognizing it's going to hit our performance budget. So that would be my number one. The other thing that I have had the most heartache on is in migrations, and a migration timing out or a migration having weird errors because we've hit a memory state where there was a problem. So memory generally doesn't affect me because there's so much caching going on. Even the CPU is going to cache things and the servers are going to cache things. So rarely does it matter unless you have that one-time process like a migration where it's all fresh data and the process may take hours to run. And so garbage collection isn't going to do as good a job as if it was running, for a fraction of a second and cleaning itself up. So as we get into more long-running processes, expect to see these issues, and you're going to all of a sudden care about things like unsetting variables, even though you're writing what looks like a simple migration. Next question, could you talk a bit about performance implications of unsetting variables versus not, assuming that the memory limit is not reached? This might be beyond my knowledge. There is an allocation of memory for a process. So an instance of your program is running. And to my knowledge, the CPU doesn't care if you have 1 or 1,000 variables currently pointed to. It's going to take some amount of time to track down those variables in your application. So I don't think there's ever an issue of having too many variables. But what can get overwhelming is if you hit a memory limit. So I think that really is the bigger problem. But this is beyond my expertise. I know a little bit about PHP internals, and I know almost nothing about how the CPU accesses memory, which is probably the bigger issue here. I'll say it is just good practice to unset things when you don't need them, or maybe more importantly, move things to smaller functions. I had a boss who would be so upset if you passed a big object to a function because he said that would double the memory. And now I can, in front of all of you, say he was wrong, because in PHP at least, it's going to have that soft copy most of the time. But there's a responsibility with, say, passing if you load multiple nodes and you really just needed the node ID of the first one. I don't know, I would feel a lot safer having a single integer over this large object, which may or may not be a problem later on. Any tips on reducing the memory usage and migrations generated by migrate update? Well, we're kind of tied in how much we could change in the migration, because some of these plugins are going to work the way they work, and they do it beautifully as far as keeping references to different things. They're also batching tasks, which is very nice. But as far as tips, I guess this is things that I've run into. Being able to, let's see, some of the biggest ones, my biggest issues have been in queries and having large data sets, and things time out more than actual memory footprints. But think about this. For migrations, keeping things small certainly makes a difference. If you're passing around a large result set and then just chugging away and iterating over it, you will probably time out. So keeping things small makes a lot of sense. Being able to post-process things later is sometimes a necessary evil. But for me, writing great SQL is often the answer. So if I could write less PHP and more SQL to do things like joins and counts and calculations, I'm going to get a more focused data set back, assuming you're talking about a migration from a database or an endpoint that's getting a lot of relational data. I don't know if I answered your questions, but yes, I would focus on the query and not the processing of the result set if you want to be more performant. That's a general statement. Anything else? I should also pull up the last slide here. So there are 2 more events coming up here, the Expo Hall and networking for the next 15 minutes, and then another round of sessions, and it's going to be hard to pick one because they are all looking really good. Well, thank you so much. I'm NGM. Please reach out. I'm also on the Slack, not just for Drupal, the Drupal Camp Asheville, but the Drupal.org Slack, and I'd love to hear your stories, especially if you know more about some of these topics than me, because I am not a PHP contributor. I just like looking under the hood from time to time.
Thanks a lot, Jim. That was a great presentation.